All right, happy day everyone. So what we're going to be doing now is we're going to be talking about acid-base pH calculations. So you need to make sure first that you have your calculator out for this part of the section. And you want to really make sure that you're trying the calculations out. So as we go through this, just make sure if you need to pause, you can pause, but just make sure that you figure out how to use your calculator before you move on. So first thing is, we're going to talk about what it means to be an acid and what it means to be a base, okay? So it says water is very, and we talked about this word, and basically the idea was that either electrons were being shared equally or unequally. And we know that with water, the electrons are not shared equally. We call that type of molecule polar. Awesome. We say that water is actually very polar. And collisions between the water molecules will transfer H plus from one to another. It says a water molecule that loses a hydrogen ion becomes a negatively charged hydroxide ion, which hydroxide is given OH minus. So in other words, if you have an H2O molecule and it loses one of the H pluses, what you're left with is OH minus. If you look at water this way as HOH. The other side says, what if you have a water molecule that gains a hydrogen ion? Well, if you get a water that gains hydrogen, instead of being H2O, now it's H3O. And H3O is written with a positive charge because now it has one extra proton. And so we say that it's positively charged. Now, there's a huge, I guess, disclaimer that's in the books. And what it says is, even though hydronium ion is really what's being produced, we're going to just call it H plus, okay? So instead of calling it hydronium, everybody say hydronium. Hydronium. So hydronium is this H3O plus right here. We're just going to call it H plus just to make it a lot easier. We're going to take a look at what it would look like if it were an acid, an acidic solution. This is just showing water right here, okay? Remember, we can't see what it looks like at an atomic or a molecular level. So instead, we use these simulations, and the PhET simulations are really nice for this. And so what we can see here is water will actually self-ionize, and when it does that, this right here is showing H3O plus. And so what it's showing is these three little Mickey Mouse things, these are the H's, and then there's the one O in the middle, and that has a positive charge. These blue ones right here are representing OH minus. Those are representing the hydroxide ions, okay? Now watch what happens when it's an acidic solution. So let's give it a weak acid solution so we can still see what's going on. And by the way, what's in the background are all of the water molecules, okay? So we're like zeroing in on, now it's an acidic solution. And in an acidic solution, what we can see is we still have these H3O pluses that were there before. We also have these hydroxides are still in there as well, but what's true now is we get these blue H pluses, and those are representing hydrogen ions that are part of an acid. Okay, and then we also get, and again, that's the H3O plus that's over there. And so the A minus, this blue one, is representing part of the acid. And so when that breaks off, it forms H3O plus, which again, we're just going to call H plus. Okay. If we had a basic solution, the reason why that would look different, let's do a weak base here, is again, we're going to see now that we've got a lot of these OH minuses that are in solution. So it'll show you the base, which the base is just this silver ball that's right here is how they're showing that. And then we just have the OH minuses that are coming off in the solution. So that's the only difference between an acid and a base. An acid will release H plus, bases will release OH minuses. Okay, so let's flip the page here. And we can see also that if you were to test the solution, if it's acidic, the pH is lower. If it's basic, the pH is higher, okay? Greater than 7. Let's take a look here. So we already talked about the fact that water self-ionizes. It says it's the reaction in which two water molecules produce ions. Water will dissociate as seen here. The water will break up and form H3O plus and OH minus. Again, what did we say we're going to call H3O plus? H plus. And then OH minus. So again, it says here we're going to substitute H plus for the H3O plus. In pure water at 25 degrees Celsius, the concentration of H plus and OH minus is actually the same. Why? Because what do you know that water breaks up into again? H plus and OH minus. So if you have equal amounts of them, then when you have a neutral solution, your H plus and your OH minus are equal to each other, and they actually found out that the concentration would be 1 times 10 to the negative 7th molar. Okay? We're going to talk about the significance of this number in just a second. So that's a neutral solution. H plus and OH minus are interdependent. What does that mean?
You rely on each other?
Yep, they rely on each other. As one goes up, the other one goes down, and the other way around. Okay, vice versa. It says the Kw is called the ion product constant for water. And Kw is H plus times OH minus, and when you multiply the two together, you get 1 times 10 to the negative 14. Here's why. Well, if we said that they were equal to each other, and we wrote 1 times 10 to the negative 7 for this one, and 1 times 10 to the negative 7 for this one, if you plug this into your calculator, and you have to make sure that you do this correctly, if you're using a TI, for example, you'd want to click 1, hit your second key in the EE, and then hit the negative 7, multiplied by, again, 1 times 10, hit the second key, EE, negative 7, and what do you get when you do that? 1 times 10 to the negative 14. Now, if you have the Casio, then what you would do is you would hit the 1, and then you hit the E button, negative 7, again, times 1 times 10, that's the exponent button, negative 7. If you have this kind, you have the EE button right there. So depending on what kind of calculator you have, remember your E will be in a different place. When you do that, you should see that you get 1 times 10 to the negative 14, which is what it says here. So the water product, the ion product constant for water, that's all they're doing is saying that when you multiply, when both of your values are 1 times 10 to the negative 7 and equal, like it is for pure water at 25 degrees Celsius, then they'll both equal that value. So it's really nice because they've turned it into an equation. So it's a pattern that they found. And as soon as if you know one of them, you can always figure out the other one using this equation. They don't have to both be equal to 1 times 10 to the negative 7. So now what we can do is we can basically say it's almost like x times y is equal to 10, for example. If you knew that y was equal to 5, how would you solve for x? Divide, right? It's a division property. And so you would divide 5 on both sides and say that it's equal to 2. That's how that equation is going to work. It says not all solutions are neutral. Some may have more of either ion. If it's acidic, your H plus is greater than your OH minus, okay? So you have more H plus. That means it's acidic, okay? In this case, if your H plus is less, or you have more OH minus in your solution, we call that what? Basic. Perfect. So it says in other words, if your H plus is greater than 1 times 10 to the negative 7, which is your midpoint, then guess what we're going to call it? If you have a high H plus, we're going to call it acidic. And if you have a high OH minus, we're going to call it basic. Okay? pH concept. So where did they come up with this pH thing? So what happens is this guy, he was a Danish scientist in 1909. His name for real was Søren Sørensen. I'm not joking. And he wanted a simpler way of dealing with all of this stuff. So instead of saying 1 times 10 to the negative 7 and 2.6 times 10 to the negative 3 and 4.5 times 10 to the negative 12, he said, can we just use whole numbers? Can we use numbers like 12.6 and 1.3? So what he did was he figured out a scale. And what he found was if you negative log these numbers, you'll actually get a whole number. For example, everybody go ahead into your calculator, and what I want you to type, depending on what kind of calculator you have, you're going to hit the negative, and then I want you to find the log button, and hit the log button. Okay, so you're going to hit the negative, and then hit the log, and now I want you to type 1 times 10, so second EE, negative 7, and hit equals. And what do you get when you negative log it?
Wait, what did you say?
7. Let's try this again. So now let's try something like 1 times 10 to the negative 8, okay? So you're going to hit the negative button, and then you're going to find wherever your log key is, and then you're going to type 1 times 10, or your exponent button, to the negative, what did I say, 8? Yeah. Okay, and what do you get? 8. So what he did was, he wanted an easier way to deal with these numbers, and he found that every time he negative logged whatever the concentration was, you get a nice whole number, okay? And the numbers pretty much range between 0, and guess what the highest is? Anybody know? 14. Perfect. What he found was when you do that, you actually get a nice scale between 0 and 14. And so that's how he came up with this scale, this pH scale. So it says he wanted a simpler way to discuss the H plus concentration, and he proposed the scale expressing H plus from 0 to 14 rather than using molarity. And what do we call it? pH. Perfect. We call it pH. It's a lowercase p and a capital H. So every time you see the P, I want you to substitute in negative log. Okay? So the P is going to stand for negative log. So you can have pH, but you can also have POH. So let me show you how that works. So then what he did was, we found out that we knew that KW was H plus times OH minus, and that was 1 times 10 to the negative 14. Well, he was able to come up with the second equation. And the second equation was, if you take the negative log of H plus and you add it to the negative log of OH minus, instead of getting 1 times 10 to the negative 14, guess what you get? 14. Well, that became the second equation. It says for a neutral solution where H plus is 1 times 10 to the negative 7, the pH is 7, we know that. pH less than 7 is called acidic. The pH for fluids in your stomach, anybody know around where that is? Yeah, it is actually somewhere around 2.6 or 2.7 is what they say. And basic stuff like household ammonia, that actually has a pH, a high pH of about 13.6. Let's label some of the pHs here. So, if it's 0 to 7, we're going to call it an acid. If it's greater than 7 to 14, we're going to call it a base. How is this easy to remember? Because in the alphabet, what comes first? A and then B. So it's really easy to remember. If it's low, it's an acid. Now, it's confusing because being an acid means it has a high hydrogen concentration. Okay? And so it's actually the reverse. If it has a high hydrogen concentration, the pH is low. In other words, the negative log of that number is low. Okay? Which mathematically works. So, let's keep going around here. So we were wrapping around before. So in the back of the row here, if the pH is 4.22, what does that make it?
Acid.
Acid. Very good. Next one, the pH is 7.63.
Base.
Base. Very good. 2.43.
Acid.
Nice. 12.45. Very nice. Okay, now we're given pOH. So, in order to find the pH, what do you have to do first? Subtract from 14. So go ahead and subtract from 14, and what do we get? 11.33, yes? Okay, well, if you know it's 11.33, so then next person, if that's your pH, then that would make it a base. Perfect. Okay, your pOH, so let's go back to the back corner, is 3.45. So go ahead and subtract from 14, and what do you get for your pH? What do you get? 10.55. So what does that make it? If the pH, yep, base, perfect. Okay, next one. The pOH is 7. What does that make your pH?
7.
Also 7. So next person, what's that one then? Neutral, very good. And last one, it's 8.99. So what if you subtract from 14, what do you get? Yep, 5.01. And so in that case, then what is that next person? What does that make it? Acid. Yep, very nice. Acid, awesome. Okay, these are the 4 equations, all right? And this is it. So we're going to talk about how to use these equations too. When you're calculating pH, you're going to type negative log, and then you're going to use the H plus concentration and hit enter, and it's that easy. When you're calculating H plus, if you're given the pH, you're going to hit inverse log and the negative of the pH, and you'll see when we do this in a second. Sig figs. When you're reporting pH, only the numbers after the decimal are significant. Only for pH and pOH. In other words, if you see something like 5.00, that doesn't count for sig figs. Only the numbers after the decimal count, so that only has 2 sig figs. So if I said pH equals 5, how many sig figs is that?
0.
0. So it would actually be incorrect to say that pH is 5, unless you were saying it's an infinite number of sig figs. Okay? So let's try this. What we're going to do is we're going to use the definition for pH in order to calculate this. So pH is equal to negative log of H plus. So in your calculator, negative, hit the log button, and then you're going to go 1 times 10 to the, what does this one say? Yep, negative 12. And what do you get? 12, but that has no sig figs. Molarity, that has 2 sig figs, so we're just going to add 2 zeros to the end. Okay? So make sure that you get that, all right? We might need to pause for a second, make sure that you get that. Now let's do the POH. Well, once you get your pH, how do you get your POH? Subtract from 14. So what would that be? 2. Awesome. Now these you don't necessarily need a calculator for, but I want you to go ahead and type negative log of this number again. So you're just going to plug that right into there, and what do you get? Do you get 2.00. But then this one then would be 12.00 when you subtract from 14. Let's try this one. Again, you're going to negative log this, and if you negative log it, what do you get? 4.00. And so when you subtract from 14, what do you get here? 10. Okay, so now we're going to continue with these problems down here, which are the same exact thing as this. We're still going to use this pH equals negative log of H plus equation in this case here. So we're going to type in, we've got our negative button, so I'm just going to hit the negative button on my calculator again. And then I'm going to type log, and then I'm going to do this 5.6 times 10 to the negative 12. And what I get here is 11.25. This has 2 sig figs, and so I also want 2 sig figs after, so that ends up working out. Now, in order to figure out what my POH is, what do I need to do? Subtract from 14. So I'm going to subtract from 14 here, and I get 2.75. Now, you always want to look at the pH to be able to tell whether it's an acid or a base. So in this case here, because my pH is greater than 7, I'm going to call that a base. Let's try the next one. Again, I'm just going to type negative log. I'm going to enter this number in, 2.6 times 10 to the negative 4. And what I get is 3.585, so I'm going to say 3.59. And again, in order to find my POH, I'm simply going to subtract from 14. So I get 10.41. Again, we're going to look here, and if my pH is less than 7, then I'm going to call that an acid. And last one here, negative log of 0.0356, and I get a 1.45, and again, if I subtract the number from 14, I get 12.55, and so that again will make it an acid. So those are pretty easy. Now, if you were given the OH minus instead of being given the H plus, instead of using pH equals negative log, guess what the equation becomes? POH equals negative log of, instead of H plus, what is it? OH minus. Awesome. Now you're using the OH minus instead. So the equation's exactly the same. So if we come back up to these equations right here, this equation and this equation are really identical to each other. The only difference is, by definition, the P stands for negative log and the P stands for negative log, but if it's the H, then you're using the H plus. If it's the OH, you're using the OH minus. So what we're going to do on this other side here is we're actually going to do the reverse. So in this case, they give us the pH and they want to know what was your concentration in molarity. So we know the equation is still pH equals negative log of H plus. But what we're looking for is this. We know the pH. So as far as our order of operations goes, the first thing that we need to do is we actually need to take the negative and shift the negative over to the other side. And so now what we get, for example on letter D is, we get that negative 5.00 is equal to the log of H plus. Now, you want H plus alone. And most of you may be thinking, well, all I need to do is divide by log on both sides. Is that the correct thing to do? Do you divide by log on both sides?
No.
No, you don't divide by log on both sides. What do you have to do? Instead, you have to inverse log. So what does that look like in the calculator? In the calculator, what you're going to do is you're going to find your second key, or your shift key. On here is a second key as well. And you're going to hit second log, and it's the 10 to the x. That's what you're trying to use. So here again, you're going to hit the second or the shift key and the log, and it's the 10 to the x. Same thing here. The second log gives you the 10 to the x is what you're trying to get. The only problem is it's a negative number, because when we moved that negative over, we need to make sure that we do inverse log negative 5. So in your calculator, you're going to type the shift key or the second key, whatever that is. So we're going to hit the second key. And then you're going to hit log. And then you're going to do negative of whatever your pH is, whatever your pH was. So in this case, if I do that in my calculator, hit the second, the log, and the negative pH, what I get is 1.0 times 10 to the negative 5, and this does have units of molarity now. pH doesn't, but this has units of molarity. And that's 2 sig figs, so this should also have 2 sig figs. And in molarity, it's the same as what we've been doing all year round, so our number of sig figs would be the same as the rules that we used before. The only thing is pH and POH, where only the numbers after the decimal count. Okay, so that part wasn't so bad. But now we need to figure out the OH minus. And there are 2 ways to do this. Some people think that one way is easier than the other. It doesn't really matter. One way is, well, if I know my H plus and I want to know my OH minus, there's an equation for that. If we look up here, this equation that we talked about earlier relates H plus to OH minus. And if you know one, just like when we were saying, if you call one X and one Y, if you know one of them and you want to figure out the other one, what do you need to do? Simply not multiply, but divide. Awesome. And so what we're going to do is we're going to plug one of them in when we know the other one. And then you're going to do this number divided by either the OH minus or this number divided by the H plus. So let's try that here. We're going to do 1 times 10 to the negative 14 divided by this number, which is 1 times 10 to the negative 5. And what we get is 1 times 10 to the negative 9 molar. That's one way of doing it. Well, the other way of doing it would be, if you know your pH, you can calculate your POH. And so what we can do is we can subtract it from 14 and say my POH is equal to 9.00. And if your POH is 9, you can use the same way that we did it here to say second log of the negative pH, and that will also give you the same answer that we got here, which was 1.0 times 10 to the negative 9. So it doesn't matter which way you do it either way and you'll still get the same answer. So let's try the next one. Well, without even calculating this, I know that the pH equal to 7, that means that this must be 1 times 10 to the negative 7 molar. But if I wanted to plug it into my calculator, I would hit the shift key again, so I would hit the second key on here, I would hit the log, and then again, you want to do negative 7, not just 7. You want to make sure that you hit the negative button on your calculator. And you'll get 1 times 10 to the negative 7. Well, if you go to do your OH minus, 1 times 10 to the negative 14 over 1 times 10 to the negative 7, you still get 1 times 10 to the negative 7 molar. So we would call that a neutral solution. It's not acidic or basic. And by the way, this one, if the pH was 5, would be an acid. All right, and last one. In this case here, our pH is 11, and so that makes it a base. So let's go ahead and write what this would be. Well, if I inverse log, second log, negative of 11, I get 1 times 10 to the negative 11 molar. Well, if I take 1 times 10 to the negative 14 divided by that, what you should get, again, 1 times 10 to the negative 14 divided by that number, I get 1.0 times 10 to the negative 3 molar. And I know that because they both have to equal the exponents. When you multiply them together, you're actually adding. And so it's negative 11 plus a negative 3, which is equal to the negative 14. So I'm just using the equation H plus times OH minus gives me 1 times 10 to the negative 14. All right. And the last thing here is same thing as this, except now you're given different numbers that don't round to this exact whole number as integers, the way that these do. So now let's plug these numbers in. I'm going to click inverse log, again, of negative 4.30. So this is inverse log, or second log, negative 4.30 in my calculator. Okay, and so what I get in my calculator is 5.0 times 10 to the negative 5th molar. And again, there are 2 ways to find out my OH minus concentration. I think the easiest way is just to say 1 times 10 to the negative 14 divided by my answer. And when I do that, I end up getting 1.995, which I'm just going to say is 2.0, times 10 to the negative 10 molar. So you may be looking at this and you may say, well, wait a minute, I thought you said that these had to equal negative 14, and that's true. That's a negative 5, and that's a negative 10, which definitely doesn't equal negative 14. So how does that work? Well, the problem is we've got a 5 times 2, and 5 times 2 is 10. And when we talked about scientific notation, we said that you cannot have a number that's greater than 9.99, and your number cannot be less than 1 when you write in scientific notation. So this would actually be 10 times 10 to the negative 15, which really, if you write this in proper scientific notation, that would be equal to 1 times 10 to the negative 14, which does check. That does match, and so that really does equal 1 times 10 to the negative 14. And you can try it in your calculator by multiplying these two together to ensure that you get 1 times 10 to the negative 14. All right, and just 2 left on here. So again, I'm going to inverse log the negative 8.65. Make sure you do the negative 8.65. And that gives me 2.2 times 10 to the negative 9 molar. So now I'm going to 1 times 10 to the negative 14 divided by my answer, and that gives me 4.5 times 10 to the negative 6 molar. And last one here, again, inverse log negative 13.26, and that gives me 5.5 times 10 to the negative 14 molar. And if I take my 1 times 10 to the negative 14 and divide by my answer, I get a 0.18 molar, or 1.8 times 10 to the negative 1, okay? Now, if they gave you the POH instead of giving you the pH, it's exactly the same. The only difference is, when you inverse log the negative of the number, you're actually going to get the OH minus. It's the same thing. So you're going to get the OH minus. So then, you would still use the same equation to get your H plus. All right, so that's it. We're going to take a look at the worksheet on here. So what you're going to do is, for example, if we take a look at the second one, you're given the POH, and they tell you that the POH is 10.24. So the question is, how do you find your pH? Well, we know that if you subtract 14 minus 10.24, that ends up giving me a value of 3.76. Now I want my H plus. So in order to find the H plus, well, I know my pH. So if I know my pH and I want my H plus, then now it's back to the problem that we were talking about before. In this case, I know that pH is equal to negative log of H plus. So I'm not looking for this. If I were looking for pH, I would simply type negative log H plus and find my pH. But in this case, I'm actually doing the opposite. So what we're going to do is we're not using this equation. We're going to use the inverse log of negative 3.76. 1.7 times 10 to the negative 4 molar. And these will all have units of molarity. So that's a molarity, and that's a molarity. This should also be a molarity that's on there as well. So now we want the OH minus. Again, there are 2 ways to do it. I can either do the same thing I just did here, or I can do 1 times 10 to the negative 14 over that answer. It doesn't matter. It's up to you. And that gives me 5.8 times 10 to the negative 11. 5.75 times 10 to the negative 11 molar. To figure out whether it's an acid, base, or neutral, you're just going to look back at the beginning, and that makes it an acid if it's less than 7. And then on this page here, what you're going to do is, and by the way, just make sure this says POH instead of saying pH on there. I think I had a typo that was on there as well. So in this case here, all you're going to do is you're just going to subtract from 14 to figure out one when you know the other one. So in these you know the pH, and these you know the POH. But it's the same equation. These, you're given the H plus, and you want the pH, and then you want the POH. So the perfect equation for that is pH is equal to negative log of H plus. And all you're going to do is just simply plug in the values there. This is giving you OH minus. So instead of doing pH equals negative log of H plus, I'm going to do POH equals negative log of OH minus instead. And that should give me the right answer for those as well. Just keep in mind, you're getting the POH first, And then you can subtract from 14 to get your pH. And the last section down here, it says, remember, you need to use the inverse log of the negative. So in your calculator, you're going to type inverse log negative pH or negative POH, depending on which one that you're given. Okay? All right, and spend the next few minutes here just working on a couple of problems in that.